Today we are going to discuss about operations on complex numbers. First one, how to plot complex numbers and how to find conjugate to a complex number. After that, let us discuss about addition and subtraction of complex numbers. Finally, in this session, I'll give you some problems for your practice. Let us see about the first point, how to plot complex numbers. You know very well, a complex number's general form is z is equal to x plus iy, where x is your real part and y is your imaginary part. So to represent a complex number, we need a plane. That plane is called by the name organ plane. The organ plane has two axes. One is x-axis and another one is y-axis. X-axis is taking the values of real part and y-axis is taking the values of imaginary part. This is your real positive side, this is your real negative side, this is imaginary positive side, and this is your imaginary negative side. We are going to plot the points as we are plotting in ordinary graph. Now let us consider a point minus 2 plus 4i. How to plot this point, where to plot this point? You know very well, minus 2 is the real part. So go to minus 2 on real axis, and from there you have to move to 4 in the imaginary axis. So here you have to mark the point. Same way, let us try to plot another one complex number, that is 7 plus 6i. Where to mark 7 plus 6i? Just on real axis you have to take 7, and in imaginary axis you have to take 6. So here the plotting will be. So 7 plus 6i is a complex number which is in this particular place. Now let us see what is complex conjugate. You know, a complex number is in the form z is equal to x plus iy, and if you want to take a conjugate to this complex number, that is represented by z bar. How to get this z bar? It is very simple. Just if you change the sign of imaginary part, then the complex number will be converted into its conjugate. It is very simple, right? Like this. So if the complex number is z is equal to x plus iy, then its conjugate is z bar is equal to x minus iy. Just there is a sign change only in the imaginary part. You should not change anything in the real part. Now let us try to plot this complex number and its conjugate in the organ plane. It's very simple. You know, x-axis is the real axis and y-axis is your imaginary axis. Let us consider like this. Let us try to mark this z is equal to x plus iy. So x is real part. It may be somewhat like this. Then y may be like this. So approximately, let us consider this x plus iy will be here. Yeah. So this is your complex number. The same way, let us try to mark the z bar, that is x minus iy, in the organ plane. The same x value on the real axis, but y value is changed. It is in the negative axis, so you have to take in this place. So approximately it will be here. So this is your z bar, that is equal to x minus iy. So now currently we have plotted both complex number and its conjugate. If you think this complex number as an object, then automatically this will be its image. It seems to be in the same way. So we can say, or we can interpret a conjugate of a complex number in this way. Conjugate of z is nothing but reflection of z on real axis. Let us do some problems on conjugation. Z is equal to 2 minus 3i. It is a complex number. Now let us try to convert this into its conjugate. That is, z bar is equal to 2 plus 3i. What we have to do is just we have to change the sign of imaginary part. Sign of imaginary part alone changed, and we have done nothing with the real part. Similar way, let us do with some other sum, that is z is equal to minus 2 minus 3i. So z bar is equal to minus 2 plus 3i, that is changed only in the imaginary part. Then let's see, z is equal to 6i, it has only imaginary part, its z bar will be minus 6i, and let us consider z is equal to 3, its z bar is simply 3 because we cannot change anything here because it has only real part. We have to change only the imaginary part sign here. We cannot do so because we have only real part. Now let us see operations on complex number. That is, simply first we are going to see how to add two complex numbers and how to do subtraction between complex numbers. Let us consider two complex numbers. Let the first one be z1 is equal to 4 plus 3i. Let the next one be z2 is equal to minus 2 plus 4i. Now let us try to add these two complex numbers. So your z1 plus z2 will be equal to 4 plus 3i plus minus 2 plus 4i. Here the important point to be noted is this. Whenever we add two complex numbers, we have to add only real part with real part and imaginary part with imaginary part. That is very, very important to remember while adding or subtracting complex numbers. So here your answer will be 4 minus 2, that is 2. 3i plus 4i, that is equal to 7i. So here we have added real part with real part and imaginary part with imaginary part. Now let us do one more sum, that is z1 minus 2 z2. So z1 is 4 plus 3i, for this minus 2 the same. For z2 we have written minus 2 plus 4i. Just multiply everything by minus 2. So it will be in taking this form. While simplifying this, we'll get the answer as 8 minus 5i. Now let us do something with bar, that is z bar also. For that, let us try to find the value of z1 plus 2 into z2 bar. So z1, you know, that is 4 plus 3i, 4 plus 2 the same. For z2 we have taken minus 2 plus 4i. For this bar we have written the same bar here. Now already you know very well, bar represents complex conjugate. Complex conjugate means we have to change the sign of imaginary part alone. We should not change the sign of real part. We have to change only the sign of imaginary part. So let's do that work. So first, this complex number minus 2 plus 4i is taken into its conjugate and it takes the form minus 2 minus 4i. That is change only in the imaginary sign. Now let us try to simplify this. It is very simple and the final answer is equal to minus 5i. I hope so you would have understood all the concepts what we have covered today.